All right, so here is graphing and writing linear equations. This is the detailed explanation for the work. So the first question says, sketch the graph of a line. And please label 3 points and 3 coordinates. We see that it is in slope-intercept form. So slope-intercept form is y equals mx plus b. And we know that we're able to pull out the slope, which is the coefficient of x. It's a number in front of the variable x. We do not include the x. Make sure we don't highlight the x part. And we're able to pull out the y-intercept. The y-intercept and the slope. Hence why it's called slope-intercept form. So with this, we see that our slope is equal to -1/4. If we turn that into slope-e's, -1 is down 1, and 4, +4, is right 4. Remember, slope is rise over run, and when we rise, we go up and down, and when we run, we go right and left. So if it's up, that's positive, down would be negative, right would be positive, left would be negative. And that's why we have -1 would be down 1. And we can't use that slope, or that slope is from one point to another. We don't have a point at the moment. So we can't use the slope yet because we have to figure out a point on the line. And the point that we're going to use is the y-intercept. It's where the line will cross the y-axis, and the y-intercept is 1. So we're going to go along that y-axis, and we're going to go to 1, because that's where this line will cross that axis, that point. We know that location on the graph. Now we're going to use our slope. We're going to go down 1, right 4. We go down 1, right 4 again, and it would take us off the graph. Or we could do the opposite, which is up 1, left 4. So we can grab a couple of points, but we need at least 3 points. And so now we have to label those points. So we'll label 4 of them because I gave 4. So some students will want to stay on the graph. Some people will move off of the graph, which is fine. Either way is all right. So this point is -4, 2. Remember, it goes x coordinate, y coordinate. This is 0, 1. This is going to be 4, 0. And this point is going to be 8, -1. And that's how we would do that problem. Next one, our slope is going to be 2. Our y-intercept is going to be 3. Slope of 2 is 2 over 1. That's up 2, right 1. So we plot our y-intercept. We go up 2, right 1, up 2, right 1, or down 2, left 1. Notice I will continue to give multiple points, more than 3 points. So don't expect, you don't have to give me more. Oh, I must have made a boo-boo there. You don't have to give me more than 3. You just have to give me 3. And that is 1, 5. And this will be 2, 2, 7, I think it is. Up 2, yep. So that's how we would graph number 2. Number 3 is still in slope-intercept form. If we turn it into slope-intercept form, that equation, we would see it as this. So it has a slope of 0, which is 0 over 1, which is up 0, right 1. We have a y-intercept of -1. So it's going to cross the y-axis at -1, and then we're going to go up 0, right 1, up 0, right 1. And this is also what we would expect. Remember, this is a unique problem because there's only one variable. Problem number 2 had 2 variables, x and y. Number one had x and y, and when it has x and y, it's going to have some form of a slope. When we only have a single variable, it's going to go through that variable's axis at that location. Or, yeah, that's fine. We have 0, -1 as my first point. We have 1, -1 as my second point. And then we have 2, -1 as my third point. Problem number 4, we have a slope of 1. Remember, when we don't see a number in front of the coefficient, we know that there's an invisible in front of the variable. We know that is a 1 in front of there. That's an invisible 1. So my slope is 1 over 1, which is up 1, right 1. We have a y-intercept of 1. Lots of 1s here. So across this y-axis, up 1, right 1, up 1, right 1. And these should actually be the 3 points that everybody gets. This is going to be 0, 1. That's going to be 1, 2. And that will be 2, 3. Those are my 3 points. And number 5, another, remember, y equals mx plus b. Nothing's being added or subtracted. So we would see this as -3/4 x plus 0. So my slope is -3 over 4, which means down 3, right 4. And then my y-intercept is 0. So it's going to cross the y-axis at 0. Then I'm going to go down 3, right 4. We go down 3, right 4 again. Or we can go up 3, left 4. Let's do those coordinates. This is -4, 3. This is 0, 0. This is going to be 4, -3. And this will be 8, -6. Okay? Number 6 now. Notice, still the same direction. Sketch the graph of each line. Please label only 2 points and 2 coordinates. Why would that? Well, because it's in standard form. These equations will be given in standard form. And standard form looks like this: ax plus by equals c. And remember, we use this, not this to find the x and y intercepts. This form is really conducive to x and y intercepts. Now, we need to remember a little something about the X intercept. The X intercept is going to cross the x-axis, and we know that when it crosses our x-axis, my y value is always going to be 0. And likewise, in its inverse, the y-intercept, I know that my x value is always going to be 0. The x, having an x value of 0 brings it down onto that y-axis. So we can use this equation, x minus y equals 5. And we know it's in standard form because the x and the y are on one side and your constant is on the other. So we will substitute a 0 in for y. And we get our x-intercept. That would be a 5, 0, because when we plug in 0, we get 5 out for x, and we know coordinates are written x, y, so that point would be 5, 0. Likewise, when we look for the y-intercept, we're going to plug in 0 for x. And that gives us -y equals 5. And we still haven't isolated the variable. We have to get y by itself. Currently, it's the opposite of y. And the way we show, almost close, almost identical intercepts. And so this is going to equal the y-intercept. And that point, when we plug in 0 for x, we get -5 for y. That would be a point. So 5, 0, and 0, -5 looks like that. And when it's in standard form, I will accept only 2 points. All you have to do is plot 2 points and label 2 points. Now remember, we could use the cover-up method. If you want to, anytime we plug in 0, it's going to take away that variable. And so we would cover it up. So if we look at this equation, if we're looking for the x-intercept, we get 0 for y. So that tells me that my x-intercept is 5. And likewise, the other way, if I'm looking for my y-intercept, I'd cover up the x value and solve for y. So that's just a little shortcut if you want to do mental math, but you see that this is the technique. This is what's happening until you grasp it completely. So I wouldn't expect you to necessarily do the cover-up or the mental math. I don't mind you doing the physical work. That's not a bad thing. So we're going to plug in 0 for y. And you see that that y value goes away and leaves us with that. That's going to be my x-intercept. My y-intercept, I'm going to plug in a 0 for x. So now we plug in a 0 into that equation. And we get 3y equals -3, divide by 3. And we get y equals -1. That's going to be my y-intercept. So now we go on the x-intercept is on the x-axis at -3. Y-intercept is -1. We go on the y-axis, -1. We connect. That's a horrible connecting of those dots. Let's go back, because that was bad. Not that much better, but somewhat better. And we really want to focus on our coordinates, writing our coordinates properly. A lot of students will flip-flop the -3 and 0 because they don't remember that all coordinates are written x, y. Let's look at number 8. Let's do the x-intercept again. Y equals 0. We're substituting 0 in for the equation, in for y in the equation. So where we saw y, we put a 0. 0 plus anything is going to give you that original item. We're going to divide by 4. We get x equals -1. That's my x-intercept. I can make that on the x-axis. Now, looking for the y-intercept, we're going to plug in 0 for x. And we get 4 times 0 plus y equals -4. 4 times 0 is 0. 0 plus y is y. And I get a y-intercept of -4. There's my 2 points. I have -1, 0 as my coordinate, and I have 0, -4 as my other coordinate. Last one. I love this one. This is a good one. X-intercept, you knew it was coming. I told you it was going to come. X-intercept, we're going to plug in 0 for y. So we get 3x minus 4 times 0 equals 0. We get 3x minus 0 equals 0. 3x minus 0 is 3x. We're going to divide by 3, and we get an x-intercept of 0. Now so x-intercept, that's where x equals 0. We're going to make a dot. Now let's find the y-intercept. And we're going to plug 0 in for x. So we get 3 times 0 minus 4y equals 0. 3 times 0 is 0. 0 minus 4y is -4y. We're going to divide by -4. And we get y equals 0. So notice that takes us to that point again. So both intercepts are at the origin. Now, the tough part of this problem, why I like this problem, is you can't find another point at the moment. There's a couple of things that you can do. You can either convert this to slope-intercept form, meaning I can convert it to, I can isolate for y. I could subtract 3x. That gives me negative 4y equals negative 3x. Divide by negative 4. And I get y equals 3/4 x. And so now I know what my slope is. My slope is 3/4. So that is up 3, right 4. Oh gosh, I didn't mean to do that. Up 3, right 4. So up 1, 2, 3, right 4. I have 2 points now. So I can do that. And I now have my graph. I have the point 0, 0, and I have the point 4, 3. The other thing you could have done is you could have just found, you find another point, and the way you do that is you use the H chart. You plug in an x value, and your equation is 3x minus 4y equals 0, and you're going to find out what the y value is. So you're going to pick an x value. I don't know, you pick 1. So you're going to plug in 1 for x. You get 3 minus 4y equals 0. You're going to subtract 3. You get negative 4y equals negative 3. You're going to divide by negative 4. You get y equals 3/4. So your coordinate's going to be 1, 3/4. Let's look at 1, 3/4 on the graph. So 1 on your x, 3/4. Oh, well, that's good. I'm glad that it did fit it. You would expect it to be on that line if it was a solution. So that's the tricky part of that one. You determine which technique, whether you want to convert it to slope-intercept form or if you want to plug in a point and find another coordinate in the H chart. Here's the other tricky one. We're still in standard form. So standard form looks like this. So I have my x value, but I don't have a b value. So, sorry, let's plug in that. There you go. So that equation, x equals negative 2, looks like this. So if we find the x-intercept, we're going to plug in 0 for y. So if we plug in 0 for y, we get x plus 0 times 0 equals negative 2. You can multiply 0 times 0, nothing wrong with that. And you get an x-intercept of negative 2. X crosses the x-axis at negative 2. Now here's the interesting part. When you find the y-intercept, you're going to plug in 0 for x. So you get 0 plus 0y equals negative 2. And you get 0 plus 0y is 0. And can 0 equal negative 2? No, that's impossible. Because 0 times y would give you 0, 0 plus 0, 0, 0 does not equal negative 2. So that is a false statement. And the reason why it's a false statement is there's no y-intercept. Remember, this has only one variable. This line is not going to cross the y-axis. It's always going to have an x value of negative 2. So find other places where x has a value of negative 2. This is negative 2, 1. Notice my x value is negative 2. This point is negative 2, 0. Notice my x value is negative 2. This value is negative 2, negative 2. Notice my x value is negative 2. If we look at those other single variable equations we graphed before, there we go. Notice y always equals negative 1. Notice my y value is negative 1, my y value is negative 1, my y value is negative 1. That's what it's saying. It doesn't matter what you plug in for x, y is always going to equal negative 1. And for the flip side here, it doesn't matter what we plug in for x, plug in for y, my x value is always going to be negative 2. So that's the logic side of that problem. Hopefully that makes sense. All right, this one, now that we are on problem number 11, now we're in point slope form. And point slope is y minus y sub 1 equals m times the quantity x minus x sub 1, where m represents the slope and your point is going to be x sub 1 comma y sub 1 equals your point. Now, the trick to this is notice what it says. Notice what it looks like. It says y minus y sub 1. So what you see here, when you look at this, you're looking at the opposite of my y value. So my point is not what I see. What I see is the opposite of my y value. And that goes the same as my x value. This says, hey, whatever you see is the opposite of your x value. So we have to really be diligent about understanding what my point is when I pull it out of here. My point, my x value is going to be the opposite of what I see. I see a negative 5, so the opposite is going to be positive 5. My y value is next to the y variable. I see a negative 2, and that represents the opposite of my y value. So my point is going to be 5, 2. And also understand that the x value is with the x, the y value is with the y. And then my slope is the coefficient of the parentheses. So it's outside of those parentheses, slope of 4. So I'm going to plot that point, 5, 2, 5 on the x, 1, 2, 3, 4, 5 on the x, and then 2 on the y. Takes me there. Now I have a slope of 4, that's up 4, 1, 2, 3, 4, right 1. Up 1, 2, 3, 4, right 1, or we could have gone down 4. 1, 2, 3, 4, left 1. I don't mind which direction. You just need 3 coordinates. So this is the point 5, 2, as we know. This is going to be 6. What's that? 2 and 4, 6, 6. Wow. Okay. And this will be 7, 10. And this point is 4, negative 2. So those should be, you should have 3 of those 4 points as your points. Whoops. Number 12, also still in point slope form. My point is going to be the opposite. My x value is the opposite of what I see. I see a positive 1, so I know it's going to be the opposite of that. My y value is positive 3, so I know it's going to be the opposite. My slope is going to be negative 2. Remember, we can't use the slope until we have a point. Slope is the rise over run from one point to another point. So don't use the slope first. You got to plot your point and then use the slope. So negative 1, negative 3 takes me here. Now I'm going to use my slope, which is negative 2, which is down to right 1, down to right 1, or up to left 1. Connect those dots, put the arrows. We have the point. That coordinate is going to be negative 2, negative 1. This is going to be negative 1, negative 3. This is going to be 0, negative 5. This is going to be 1, negative 7. 1, 2, 3, 4, 5, 6, 7. Just double checking, and that's good. All right, what do we got here? We've got, still in point slope form, my point is going to be negative 2, positive 4 with a slope of 1/3. So negative 2, positive 4 takes me there. Slope of up 1, right 3, up 1, right 3, or down 1, left 3. And when you do these enough, you should be able to do this work this efficiently and this quickly. But that only comes with practice. 1, 2, 3, 4, 5. That's negative 5, 3. That's negative 2, 4. That is 1, 5. And that is 4, 6. Now, if you want to get, no, I won't get into that. But you'll notice there's a pattern in your increments from your x's, -5, -2, 1, 4. That's increments of 3. And you notice your y values are 3, 4, 5, 6, increments of 1. And that is also derived from the slope. If you understand that, great. If you don't, you can work on that. See if you can figure out why I just mentioned that. That's a nice little pattern there for you to take a peek at if you want to learn a little bit more, understand slope and all that a little bit better. Let's go over our point. Our point here is going to be 2, -1 with a slope of -1. Here we see it again. We see that negative. So this is really, there's an invisible -1 outside of that parentheses. When we see a negative out there, that represents a -1. Hence why our slope is -1. Let's plot the point, 2, -1. My slope is -1. -1 is a fraction, is -1/1. That's down 1, right 1. There's only one negative there. You can put it in the numerator or denominator. You can't put it in both. Down 1, right 1, down 1, right 1, or up 1, left 1. Coordinates are 1, 0. Here we have 2, -1. Here we have 3, -2. And the last point is 4, -3. Again, you'll see that pattern that we had talked about. 1, 2, 3, 4, 0, -1, -2, -3. And the last one, here we should notice things that we should be observing. Hey, I notice that this only has one variable. So what is that in point slope? Point slope, that's going to look like this. And it's going to be 0 slope. And I'm pretty sure it's going to be that. No, that's not what it's going to be. How do we do that? How would we write that in point slope? It would be that. It would be that, but yeah. Our point would be -2. No. -2, 0. That doesn't make sense. I've never thought of this way. Trying to write it in point slope form. You factor out, you can't factor out. This is going to cross the y-axis at 2. So -2, 0 would not be correct. All right, I'll have to think of that. That one's got me stumped. I do know that it crosses the y-axis at 2. My y value is always going to equal 2. So I got to make points that have y values of 2. Where's another point that has a y value of 2? We can pick that. We can pick that. But those values, those points, all have y values of 2. So this is 1, 2, 3, 4, 5, 6, -6, 2. This is 0, 2. And this is 4, 2. Notice all my values have a y value of 2 because that's what the equation says. So I'll come back to you. I will think about that on how I can write that in point slope form. That one's got me stumped. So we can't rewrite it as another. We just have to recognize that that is a single variable. All right, now we've just been graphing all these. Now we're going to write these equations in each form that it asks for. So it asks for slope-intercept form. So I'm going to write the template, and then I'm going to fill in for, we know that in this template, in order for it to be in slope-intercept form, I have to fill in for the slope, and I have to fill in for the y-intercept. So looking at the information, can I derive the slope? Yes, it gives me the slope. I'm going to plug that in for m. And then does it give me the y-intercept? Yes, it gives me the y-intercept of 1. So this is real easy. This is very basic. They literally give you the information. So you just plug and play. And the next one, This time they give me the slope, but they don't give me the y-intercept. So I again start off with my template, and now I'm going to fill in part of that. I know what my slope is, but I gotta figure out, I still owe the y-intercept, but they didn't give me the y-intercept. Notice they gave me a point, and that point is an x and y value. So I'm going to plug that x and y value into that equation. So my y value is 4, my x value is -2, and I'm going to be able to figure out what my b is by solving for it, isolating it. So it's giving me some help. I'm going to isolate it. That gives me 16 equals b. Now I know my b, so I can write my final equation in slope-intercept form with the slope and the y-intercept. So sometimes you have to give that information and utilize the alternative information in order to find the intercept or the slope that I am looking for. Okay. The next one, so remember, we start off with this template. Why this template? Because it wants it in slope-intercept form. So the first thing I'm going to do is I'm going to find the slope. I was given 2 points. I'm going to use y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's the easiest way to find the slope when given 2 points. This is going to be my x sub 1. This is my y sub 1. It's my x value for my first point. That's my y value for my first point. This is my x value for my second point and my y value for my second point. Now I'm going to go back and substitute it. Y sub 2 is -5 minus my y sub 1 is 3 over x sub 2, which is also -5, minus my x sub 1 value, which is 1. That gives me -8 over -6, which gives me -4 over -3, which simplifies to 4/3. So now I've taken that and I can add a piece to my template. I know my slope is 4/3. Oh, can I take that apart? Let's see. Let's move this around. Oh, because I want to move it down. I want to have space here. Let me take that. Can I take you? Can I take you too? Oh, yes. Nice. I like it. Okay, let's put that there. Let's put that there. And that looks a little bit better. I have space for my work. So now I still need to find my y-intercept. I can pick either point. I'm going to pick the first point. It's just going to be easier. And I'm going to plug that in for x and y. So my y value is 3 equals, let's move it over a little bit, 4/3 times 4. Oh, sorry, not 4, times 1. My x value is 1 plus b. So we get 3 equals 4/3 times 1 is 4/3. We're going to subtract 4/3. Subtract 4/3. You better know your fractions. So 3 1/3 is 9/3. So 9/3 minus 4/3 gives me 5/3 equals b. Wow, is it really that crazy? That's a good one. That'll be real good. See whether you know your work. Plus 5/3. Wouldn't that be awesome if that's the answer? I hope it is. I don't see where I made a mistake. I think that's correct. So that's a real good one. If you can do that one, you know that. All right. So here we're given a graph this time. We still have to write it in slope-intercept form. Now we could go and pick 2 points. We can pick 2 points and then do what we did here, find the slope, and then plug in for the y-intercept. Or we can be really smart and be able to find the slope. Well, the slope's going to go from one point to the other. We go up 1, 2, 3, 4, 5. Right 1, 2, 3, 4, 5. So I know that my slope is up 5, right 5, which translates up is positive 5, right is positive 5, so I have a slope of 1. And now, can you tell me where it crosses the y-axis? Yeah, -2. So I know my y-intercept is -2. So we can take that information and plug it in to the equation. Notice I did not write 1x. Do not write y equals 1x minus 2. Do not write a 1 in front of that variable. The proper way of writing it is just x. Okay? So, fair warned. Good. So that's nice and easy. All right, now let's write this in slope-intercept form. Slope-intercept form. Well, we know that slope-intercept form is y equals mx plus b. We have isolated the equation for y. So this is in standard form, so let's isolate y. The first thing we're going to do is we're going to get rid of the x from that side of the equation. That leaves us with 2y equals -5x plus 4. Excuse me. Now we have to get rid of the 2. The 2 is multiplying, so we're going to divide everything by 2. Knowing how to manipulate equations is going to be extremely important for you to get into geometry. This is the most basic element of algebra, is moving equations around. If you can't do this properly, you're going to struggle passing the placement test. So that's a good question right there. All right. Now we're going to move everything into point slope form. So we have to know what the template for point slope is. Remember, it's y minus y sub 1 equals m times the quantity x minus x sub 1. So what is my y minus my y sub 1? My y sub 1 value is going to be -4. So it's minus -4 because it says y minus the y sub 1. Y minus the y sub 1 equals m, which is the slope, -1/3, times the quantity x minus the x sub 1, which is 3. Now, the final answer, we don't want to simplify. We're not looking to simplify it. We're trying to write it in point slope form. So it has to have the y adding to a constant equals the slope times the quantity of x and its value. So don't simplify out that, don't distribute that -1/3 in, okay? We can simplify those double signs. I definitely want to see that. So be careful with that. Good. And you notice that your y value, your x value went in there. Let's try the next one. Now, we can do this. This is interesting. We need to know that we were given a point, but there are an infinite number of solutions for this equation in point slope because there are an infinite number of points. Remember, this represents the slope and a point. We know that there are an infinite number of points that are solutions. So we could do this. We know the y-intercept is a coordinate. It's a point. And that point, that coordinate is y-intercept. It crosses the y-axis at -5. So that point is 0, -5. So when we use point slope, we can use that as a point. So my y value is going to be minus my y value, which is -5, equals my slope that was given, x minus 0. So my final answer would be this. And I'm okay with you leaving it like that. Do not do x minus 0 is x multiplied 2 times x. That is the correct answer for this problem. Now, this is the fun one. So we need the slope. We're given 2 points, we need the slope. So we're going to use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we will assign it x sub 1, y sub 1, x sub 2, y sub 2. So if we plug that in, y sub 2 is 1 minus my y sub 1, which is 5, over my x sub 2, which is negative 5, minus my x sub 1, which is negative 3. That gives me negative 4, and we can see that as negative 5 plus 3, which is negative 2. Negative 4 over negative 2 gives me positive 2 as a slope. And now we can pick a point. Let's pick this point as the one that we will substitute into our template. So it says y minus my y sub 1 is 5 equals m, my slope is 2, times the quantity x minus my x sub 1. So we can simplify that, and we mean simplify meaning getting rid of those double signs. I expect you to get rid of the double signs. Good? Write in standard form. Okay, now we are in standard form. We're in point slope, but we have to move it to standard form. Standard form looks like this, ax plus by plus c. We need to remember that a, b, and c must be integers. Integers are whole numbers and they're opposites, meaning they're not decimals and they're not fractions. And then we need to remember that a must be positive. That's not how you spell positive. So x and y have to be on the left side, and my c, my constant, has to be on the right side. So looking at this equation right now, y equals 3/4 x plus 1, I see that my x isn't on the proper side. So I got to move that term. That leaves me with negative 3/4 x, let's move it over just a little bit, plus y equals 1. Now I got a couple issues. A, B, and C. What is A? A, right now, my A value, let's use a highlighter, my A value is negative 3/4. My B value is going to be positive 1. And my C value is going to be also positive 1. So are they all integers? No, they are not integers. A is a fraction. And not only is it a fraction, but A must also be positive, and A is not positive right now. So what makes this a fraction is that 4 in the denominator. So if I want to get rid of a 4 in the denominator, I'm going to multiply it by a 4 in the numerator. I am not taking the reciprocal. The reciprocal will get rid of it as the A value, but it will create more problems down the road. We're only concerned about the denominator, and that's 4. Now we also have to make it positive. So what can I multiply a negative to make it a positive? Another negative. A negative times a negative will make it a positive. So this leaves me with, and I have to multiply this by all 3 terms, all 3 pieces. So negative 4 times negative 3/4, the 4 in the numerator and the 4 in the denominator are going to cancel. The negative and the negative are going to cancel, and it's just going to leave me with 3x. Then I have to multiply negative 4 times y, which is negative 4y, and negative 4 times 1, which is negative 4. And this is my answer in standard form. A, B, and C are integers. 3, negative 4, negative 4, those are integers. And my A is positive. Now we're given it in point slope form. So we were given in slope-intercept form, had to convert it to standard. Now we're given in point slope form and have to convert it to standard. So I'm just going to distribute this. This is the easiest way to do this. And I can do that. Negative 7/3 times 3. Numerator, denominator are going to cancel. Hence why I'm left with just negative 7. And now I'm going to move things around. So I got to get my x on the left side. So I'm going to add 7/3 x. We're going to write the x first because standard form is xy equals the constant. Now I got to move that constant on the left side over with the constant on the right side. So we get 7/3 x plus y equals -3. Now my a value is 7/3, my b value is 1, and my c value is -3. So my a is positive, which is good, but it's a fraction. I got to get rid of that 3 in the denominator by multiplying it by a 3 in the numerator. So 3 times 7/3, the 3 in the numerator and denominator cancel. I'm left with 7x plus 3y equals -9. And that would be the equation in standard form. Now, write in standard form. So, all right, well, they gave me a point and they gave me the slope. So I'm going to use point slope form. So I'm going to use a template first to be able to get it down into an equation, and then I will manipulate that equation into standard form. So y minus my y sub 1 is -5, my slope is -2, my x value is 4. So I'm going to rewrite this. Now, I can't move things because I got to distribute this -2. I got to simplify this equation a little bit. So we get y plus 5 equals -2x plus 8. -2 times x is -2x. -2 times -4 is +8. Now I got to move my x over. I get 2x plus y plus 5 equals 8. And now I'm going to move that constant over with the other constant, because we want the x and y by itself on one side and the constant on the other. So 2x plus y equals 3. Now we have 2 points. We don't have any slope. We don't have an intercept. So I am going to, neither of these is the y-intercept. So I'm going to, again, have to use point slope form. Not fun, because there's a lot of work, but y minus y sub 1 equals m times the quantity x minus x sub 1. I got to find the slope first. Remember, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. My y sub 2 is -3 minus 3. Oh, baby. 1 minus -5. That gives me -6 over 6. So my slope equals -1. So I'm going to pick a point. I'll pick this point. You can pick either one. I'm just picking the first one because that's my y sub 1 and x sub 1. So y minus 3 equals -1. Notice I wrote -1 here because it's not my final answer. We don't want to see that -1 as a final answer, but intermediate, we can write it. X minus x sub 1. So we get y minus 3 equals -1 times x plus 5. Let's distribute that -1 into the parentheses so we can get rid of the Chewbacca arms. That gives us y minus 3 equals -x minus 5. Let's move the x over. X plus y minus 3 equals -5. Let's move the constant. X plus y equals -2. That would be my answer. That's in standard form. And the last one, hopefully the last one, and the last one is they give you a graph. I'm going to make this easier on me. I see I have the y-intercept. I know my y-intercept is 3, and I can also figure out my slope. And my slope, I'm going to pick 2 points, and make sure you pick a point that is on a grid line. I'm going to go up 1, 2, left 1, 2, 3, 4. So up 2, left 4. Up is positive, left is negative, so that gives me a slope of -1/2. So I'm going to use, since I have slope-intercept, I'm going to take that. My slope is -1/2. My intercept is 3. And now I'm going to manipulate this equation. I'm going to get my x over to the other side. That gives me 1/2 x plus y equals 3. Now I'm not done because my a is a fraction. I got to get rid of that 2 in the denominator. So I'm going to multiply by a 2. And then I'm going to distribute it to each of the 3 pieces. That's the one thing that I find students make a mistake, is they don't distribute it to the y. That's a 6. And that would be the equation. All right, that was a lot of work. Took about a half hour. But you got it. Practice, practice, practice. Good luck. I'll see you.